Solving rational equations. All right, for example 1, we have a rational expression equivalent to another rational expression. When there's only 2 separated by an equal sign, we're simply going to cross multiply to solve. You might remember cross multiplication as the butterfly method. So I'm going to take top left, multiply with bottom right. So that would give me 20 times x minus 2. You bring down the equal sign, and then you top right with bottom left. So 5 times 3x minus 5. Distribute on both sides. So that's 20x minus 40 equals 15x minus 25. All right, I need to subtract 15x from both sides. That would give me 5x minus 40 equals negative 25. I then add 40 to both sides. That would give me 5x equals 15. And then divide both sides by 5. So x equals 3. So the solution to this equation is 3. You could always check your solutions, because if they don't make sense, you did something wrong. Again, always check your work. So that's 20 over 3 times 3 minus 5. And it should equal 5 over 3 minus 2. So that's 20 over 9 minus 5 equals 5 over 3 minus 2. So that's 20 over 4 equals 5 over 1. 20 over 4 reduces to 5 over 1. So both sides work. So again, always check your solutions anytime you're solving an equation. Don't just take one solution and run. Now in this particular case, I have multiple expressions on each side. So I need to find my LCD first. So the first denominator is x. The second denominator is 3. And the third denominator is x again. So that means the LCD is x and then a 3. So these both have x, so I'm still only going to write it one time. And then 3, and that's all we need. So I then will take my LCD, which is 3x, put it over 1, and multiply it to every fraction or expression inside. That means times here, here, and there. So that would give me 3x times 8 over x plus 3x times 11 over 3 equals 3x times negative 14 over x. Now this step is not necessary to show, but I'm demonstrating it this first time so that you can understand what happens and you won't have to show it next time. But if you don't understand, please show it every time until you do. So as we've demonstrated in the past, anytime you have like terms on top and bottom, they cancel each other out. So my x's cancel there, my 3's will cancel here, and my x's over here. If you notice, all 3 of my denominators disappear, which means I don't have to worry about them anymore. I now just multiply what's on top. So 3 times 8, that's 24. Bring down the sign. X times 11, 11x. And 3 times negative 14 is negative 42. You can use this strategy anytime you have fractions in an equation. If you don't like fractions, this is the only way to make them disappear mathematically and correctly. Find that LCD and apply it to every term. if you want fractions to disappear. Now it looks like any regular equation. So solve for x first, subtract 24. That leaves me with 11x equals negative 66. Divide by 11, x equals negative 6. And then you could always check your solution. Over here, find the LCD first. I would put 2 over 1 so that it looks like the others. So my first denominator is x plus 3. My second denominator is 1. My third has x plus 3 and x minus 4. So my LCD is x plus 3 times x minus 4. So the common factors, again, you write only one time and then all the other information. So now I'm going to distribute my LCD, which is x plus 3, x minus 4, to all of the terms. I'm not going to show every step, just going to show what's left over. So on the first term, the x plus 3's will cancel, leaving me with x minus 4 and 3x plus 5. Bring down the equal sign. On the next term, nothing cancels, so everything else stays. I'll write the 2 up front though. So x plus 3, x minus 4. Oh no. Plus sign, bring it down. When I distribute it to the last term, both x plus 3 and x minus 4 disappear, so I'm just left with the numerator, which is 8. Now I need to multiply properly, again using the box or the FOIL method. X times 3x, 3x squared. X times 5, 5x. Negative 4 and 3x, negative 12x. Negative 4, positive 5, negative 20. Over here, I'm going to distribute the 2 to x plus 3, which would give me 2x plus 6 before I multiply it with the minus 4. Let's go ahead and combine 5x with negative 12x. So that's 3x squared minus 7x minus 20. Over here, multiply 2x with x. You get 2x squared. 2x with negative 4, negative 8x. 6 and x, positive 6x. 6 and negative 4, minus 24. Bring down the plus 8. Alright, bring down 3x squared minus 7x minus 20. Bring down 2x squared. Combine negative 8 and 6x, so that's a minus 2x. Combine negative 24 and positive 8 to get a minus 12. Or is it 16? 16, yes. Minus 16. Now, since it's quadratic, I must bring all terms to the same side. So I'm going to move 2x squared by subtracting from both sides. I'm going to move 2x by adding to both sides. And I'm going to move 16 by adding to both sides. If this is too fast for you and you want to do it in individual stages, that's perfectly fine. The objective is to get 0 on one side. It could be on the right, it could be on the left. That's your choice. So that leaves me with x squared minus 5x minus 4. You could try to factor it, or you could use the quadratic formula. Let me recap. Hold on one second. After further examination, this is not going to be factorable, so I'm going to use the quadratic formula. A is 1, B negative 5, and C negative 4. Again, the quadratic formula, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So that would be a positive 5 there, a negative 5 here, positive 1, negative 4, positive 1. So that's 25 plus 16 over 2. So 5 plus or minus the square root of 41 over 2. And that is not going to be very nice. So let's go ahead and take it to the hundredths place then. So that's 5 plus square root of 41 over 2, and 5 minus square root of 41 over 2. So I got 5.70 and negative 0.70. Let's take a break and look at the graph to make sure everything is proper. If I want to check with the graph, I would need all terms on one side and put it into y equals. So I'm going to have the 2 first, then plus, and then 8 over parentheses x plus 3 and x minus 4. So that was already there, but I'm going to bring this expression 3x plus 5 over, so I'm going to have to subtract it. So 3x plus 5 over x plus 3. And then graph it. So the solutions are going to be the x-intercepts. So I should have a negative 0.70 and a positive 570. So alpha trace, or second trace, 0. So the first one should be between negative 1 and 0. And that's right. So yes, our math is right. But you just wanted to double check. Okay. Alrighty. Last example. I will help you establish the LCD, but I want you to finish it on your own. So the first denominator is x squared minus 16, which is the same thing as x plus 4, x minus 4. The second denominator is x plus 4. And the third denominator is x minus 4. So that means the LCD is going to be x plus 4 times x minus 4. Now multiply the LCD with the equation. It says also to check for extraneous solutions. An extraneous solution is a solution that does not satisfy the original equation. So when you find your solution or solutions, one of them or both of them will not work. Identify which one that is. This concludes your lesson for the day.